more, Thom, D-Wave Quantum has been the first company to sell quantum computers. What has been the essence which made you so early on the market?
Well, that's a great question. I started with an effort to sort of pioneer in sort of quantum computing really early. We started in 1999, and that gave us an opportunity to really look at the field of what are the technologies we have to bring together to make a computer out of quantum technologies, a device that can turn quantum mechanics into useful work. And that early start allowed us to explore various models of quantum computing and choose carefully so that we could provide practical business value early on in the development of the technology and continuously so that we could create a roadmap for developing a large-scale quantum computer with progress and successes along the way.
Mm-hmm. Your latest generation of computers has about 5,000 qubits. This is much more than anyone else has. Why is this possible?
Well, it's because we made a choice early on. When we were studying quantum computing, we realized that there were some major engineering challenges that needed to be overcome in order to be able to make these programmable quantum systems at large scale. And we surveyed the field and realized that there was an opportunity to choose a model of quantum computing that would relax some of these engineering challenges and would also be applicable to business problems earlier at like a lower level of integration. So that was to choose the annealing model of quantum computing. It basically uses quantum mechanical effects to allow you to move between solutions quickly. And that choice allowed us to scale much more quickly and get to larger scale devices. And because we were the first mover in that space, we're sort of the only commercial provider of annealing quantum computers.
If I talk to other participants at this conference, they talk about superposition and many of these classical quantum mechanic effects. Nobody talks about annealing. And you mentioned just before the term annealing. What is annealing?
So a good way of thinking about annealing is to think about like the origins of annealing in terms of metallurgy and sort of like sword making and things like that. So that's a situation where you take like a metal material and you heat it up to change its properties, and then the way that you cool it down determines its properties when it's cold again. If you cool it down really quickly, you can basically freeze the crystals, and so you have small crystal growth, and you end up with a very hard metal, which is good for keeping an edge. But if you cool it down really slowly, it relaxes, you get long crystal growth, and that creates a metal which has high thermal conductivity, electrical conductivity, and it can be ductile, so it can be drawn into wire. So you can change the properties by speeding up or slowing down the rate with which you anneal metals. So the same principle holds with quantum annealing. You take an important business challenge or a problem, you map it to a quantum system, and then what you do is you basically expand an exploration through all of the solutions and then slowly anneal back and hone in, localize on the best quality solutions. The quantum system is able to sort of find harmony and reduce the frustration in the optimization problem using quantum mechanical effects.
Mm-hmm. So then the annealing is not an effect on electrons or on the solid matter itself. It's more a term for your business model or for development model. Do I understand correctly?
It's a model for how to use the quantum effects to solve problems. So in one case, let's say if you're going to work on like a whole problem in one step and then sort of slowly converge on a solution, that's the annealing model of quantum computing. And really the quantum mechanical effects are exploring solutions and transitioning between solutions quickly. An alternate model would be the gate model, where you're going to apply a series of short, small gates on quantum devices in order to perform little logical operations in a long sequence. And that's really for applications in quantum chemistry or in solving differential equations. So there are two models to use quantum effects, like you were referring to superposition and tunneling and entanglement. Yeah. So both models are able to leverage those quantum mechanical effects, but in the gate model, it's about allowing your computer to store more information and process over it. And in the annealing model, it's about moving between solutions quickly, and they have different core applications.
Who's a typical client to buy your products? And what problems do they want to solve with your computers?
Yeah, well, we're seeing a lot of interest from folks in industries like logistics and scheduling and manufacturing. Also in the life sciences industry, as well as in finance. So in logistics and scheduling, it might be applications like employee scheduling or moving autonomous vehicles around a manufacturing floor. In the life sciences, it might be drug trial optimization. There's a company, Minton AI, which is looking at protein design for therapeutics. And so they're actually designing proteins amino acid by amino acid using quantum hybrid methods. Mm-hmm. And in the finance space, CaixaBank has been doing work on investment portfolio hedging and also bond portfolio optimization. So those types of problems in those industries map themselves very well to the model of quantum computer that we provide in the cloud right now.
Well, traffic control, drug development or drug design, and all these problems that you mentioned are already being solved with classical computers. And we are talking a lot about the quantum advantage. What advantage has then a quantum computer delivered by D-Wave Quantum?
That's an excellent question. So we've actually done some work in quantum material simulation and shown that we can characterize the properties of these materials. And in those calculations, we published a paper in Nature Communications showing that we can calculate it with our quantum computer 3 million times faster than a classical computer. Mm-hmm. What's really significant about that was that advantage materialized in 2 product generations. So we went from not being able to calculate its properties to being 3 million times faster in those 2 product generations. That creates a dilemma for those in business. You know, if you have an application space where quantum computing can provide an impact, how quickly is that going to disrupt your business, and how do you adapt to it? So we've really tried to create products that allow businesses to get the benefits of disruptive technology of quantum computing without the negatives. And the negatives are really having to stare into a crystal ball and predict the moment when it's going to take over in your industry, or having to quickly transition your application in a rush. So by building on our quantum hybrid technologies, companies can get the benefits, the complementary benefits of both classical computing and quantum computing in their application, as well as all of the compounding benefits of the maturing technology stack, from the hardware through the software methods, in terms of applying quantum computers to those applications.
Talking about the undesired effects of quantum computer. I'm not talking about anybody developing an atomic bomb with your method or with your computers, or terrorists and so on. But a real threat could be the power of quantum computers on encryption, respectively decryption. And it's said that any method of today for encryption will be useless because the quantum computer is so fast that it will crack any code, any algorithm in no second. What do you think about that threat of quantum computing?
Well, I think it might be the reality of it might be a lot less tense than maybe what we worry about. I think that what was significant was the algorithm development sort of showed that there are ways to do to factor numbers much more efficiently with quantum computing than with classical computing, and therein lies the fear. But with the benefit of understanding, there are lots of talented mathematicians and scientists who can develop encryption methods that will allow us to continue to conduct business on the internet securely and safely with quantum-resistant protocols. And our focus is not necessarily to bring those kinds of negative changes, but largely to sort of gain and harness the capabilities of quantum mechanical effects to enable businesses to operate, more effectively or respond more quickly to change. However, the the challenge with quantum computing is that there's so much about, what is possible that we don't yet know. And the systems are sufficiently large now that new capabilities can emerge quickly. And that's forcing, I think, academia and business and government to really focus on, being ready and studying the system so that we can understand their capabilities and anticipate them, create a roadmap for how to benefit our economy and just get all the benefits and sidestep any...
Give me a short draft of the future, how you see it with the benefits of quantum computing. Design the future.
Well, I think the way I would love to see this work is that I want to take these complex topics and make them as easy as possible. So there's a broad community here at this event at QuantumBasel to study quantum effects. There are physicists, there are computer scientists, there are mathematicians who are all involved. And so by using open source software like our Ocean software development kit, each of those community members can kind of come into the technology stack at their layer and contribute their innovations in order to make better use of quantum computing and applications and benefit those who are developing applications. And so what I'd like to see is that we build programs and education and engagement that makes it really easy for software developers in small teams of 2 or 3 to understand the methods of using the technologies and programming high-valued features for their applications quickly. Because quantum computing is a tool. I began building quantum computers to benefit those with important applications. And I would really like to see that used by businesses, just like I was saying, to operate more effectively and to be able to respond more quickly to change, because nothing interests the folks at D-Wave more than to hear about how people are able to use the quantum computers in their applications and in their businesses.
Okay, thank you very much for that interesting talk.
Thank you, Pete.